This video is about the Tufts University Center for Engineering Education and Outreach Robotics Comparison Project. The focus of this project was to create the same four-wheeled robot with a front-facing claw out of 6 different robotics platforms to be able to do a direct comparison and evaluate the strengths and weaknesses of each platform. First up is the Matrix robotic system. One of the great things about the Matrix system is it comes with a really good storage container, which allows you to quickly find pieces as you're building and stay organized. The Matrix parts fit very tightly together, allowing you to create strong, sturdy builds, and it's really easy to change direction and build three-dimensionally using their color-coded joiner system. Integrating Lego pieces with your Matrix builds is also really easy. The holes line up really nicely, and you can tightly screw down the pieces to connect any NXT build with your Matrix robot. Some cons about this system is that the parts are really time-consuming to put together, which makes it really hard to change things mid-build. The motors are also really bulky and cylindrical, which can be hard to build around. There's lots of core components that have to be incorporated into your robot build. If you're using an NXT brick, you have to have that. You also have to have the Matrix core system and this big battery pack, and there's really no good way to anchor down that battery pack, so that's something that can be sort of a challenge. Also, the wheel size differential is a bit of a challenge when you're building. They give you 2 really big wheels, but then the next size down is much smaller and doesn't really support all the heavy components that need to be supported in your build. Next up is the VexIQ system. VexIQ is sort of geared towards elementary school students. A major pro about VexIQ is that the parts assemble quickly and they fit together really tight. It's a pin system and you really don't have a lot of wiggle room, which is a nice plus. The cortex and the motors are easy to build around. They're very rectangular, so you don't have a lot of contours that you have to worry about incorporating into your build. And the gears also line up super easily. They snap in, they fit tight, so that's another major plus about this system. Some cons are that it's really hard to take the pieces apart. The pins really fit in tightly, so they're hard to remove. And especially for younger kids who maybe start building and then realize they want to go down another path, it can be frustrating to have to, try to pry those pieces off. The storage container is also really mediocre. It's kind of just a large bin with some smaller storage on top. And VexIQ gives almost an overwhelming amount of pieces. And so when you have sort of this big bin, a lot of times the pieces just wind up getting thrown in there and then they're really hard to find, which can be frustrating when you're trying to complete a build. Next up is the LEGO Mindstorms EV3. Some pros about this system is that the parts assemble really quickly and are easy to disassemble and then reassemble mid-build. They give you a really good quantity and variety of pieces, which allows for a lot of diverse solutions and creativity as you're building. In addition, you have the capability to program right on the EV3 brick, which allows you to test how your pieces are fitting together, especially around a motor, to make sure your gears line up as you go, which is a really nice function that EV3 offers. Some cons about the system is that the pieces don't always fit and stay tight together. A lot of times they tend to wiggle apart, which doesn't create super sturdy builds. You also have the issue of incorporating the motors and the EV3 brick into whatever you're building. They're kind of bulky and oddly shaped, which can be a challenge. The gear system is also a bit of a challenge with this system. You have some different gears that only fit with each other linearly, and that can be a little bit of a struggle. Also, the wheel size difference was a challenge, especially in building a 4-wheeled car. EV3 sort of lends itself more towards a 3-wheeled car, and the size difference in the wheels is definitely a struggle when you're building. And even the size of the bigger wheels is a little small compared to the size and the weight of the EV3 brick that you're most likely going to be supporting. Next up, we have the Tetrix Prime robotic system. Some pros about this system is that the parts assemble really quickly. It's also easy to build in 3 dimensions. They give you a lot of variety of different angle pieces that fit really well with the beams. If you want a tight fit with these pieces, you can achieve that using their screw system, and they give you a good quantity of pieces and options for screwing them in different ways, which is nice. It's also really easy to build around and incorporate the motors. They fit really tightly with the structural beams, and that's a good plus. Some cons is that there's no good way to fasten the battery and the controller to the build, so they just sort of hang around, which isn't necessarily the most functional. And also the plastic pin system that they offer you is not a tight fit at all. There's a lot of wiggle room when you try to use the pin, so you're confined to having to use the screw system if you want to get a tight fit. Next up is the Vex Robotics system. Some pros about the Vex system is that the pieces fit really tightly together and your builds are going to be really strong and really sturdy. It's easy to attach and fasten the cortex and the battery to whatever you build, which is another nice plus. They give you a lot of different zip tie options, so nothing is sort of just hanging off your build. The motors are easy to integrate into your build. They're nice and light. They fit really well with the structural pieces, so that's another major plus. Some cons is that there's no storage unit that accompanies the VEX system, and there are a lot of pieces. So that can be a major negative, especially if you're using VEX in an educational setting where you're going to store all these variety of pieces and keep them organized can be a little bit of a challenge. The parts also take a really long time to assemble and disassemble and are hard to change mid-build. They do offer a plastic pin system to allow you to temporarily attach different pieces, but the pins fit so tightly that it's almost morphing the plastic, and then when you try to take the pins out to put screws in, sometimes the plastic will actually snap. Last up is the Tetrix Max. Some really good things about Tetrix Max are that the pieces fit tightly together. It's another metal and screw system, so everything is really sturdy. It's easy to attach any LEGO NXT components. The holes line up nicely and you can use screws to really secure those parts down. There's also a lot of options for connecting because they use that circular hole system, so you can sort of place parts at a lot of different locations along a beam, which is kind of nice. Some cons about Tetrix Max are that the parts take a really long time to assemble and disassemble, especially because of the three-walled nature of the beams. It can sometimes be really hard to fit the nuts and the screws together. Also, the shaft collars didn't really stay tight along the axles. They were sort of coming loose and didn't allow for a really tight fit. And the servo motor casings didn't attach easily to the rest of your build. So sort of the whole point of putting a servo motor in a case is so you can more easily attach it to other components. And this really wasn't the case the way they had designed their servo motor casing. If you'd like to learn more about this project or see more about each individual build, please feel free to visit our website.